cul-de-sacs are extremely common in land development. You can create them, of course, using Civil 3D alignments, but those alignments you can create in a couple of different ways. You can create those alignments from AutoCAD entities such as polylines, or you can create them using Civil 3D's layout tools. Here's an example of cul-de-sac geometry created using polylines. Looks fantastic, everything works nicely, but what if we need to change the radius of these two curves? Pretty much unusable at this point. So creating a cul-de-sac geometry using polylines, though it works in the beginning, it's quite difficult to make edits afterwards. Here's an example of an alignment created using Civil 3D's layout tools. All right, I want to change the radius. I can make this one larger. Tangency is maintained. I can change the radius of the main cul-de-sac bulb as well. Again, tangency is maintained. Even changing the offset of the incoming road and the outgoing road, still tangency is maintained. In this case, what started out as a perfectly usable cul-de-sac geometry, after edits, is completely unusable. This one, on the other hand, is completely usable after pretty much any edit you'd like to make. So how do we create this type of alignment? Well, here's the type of entities that I used. First, I created a fixed line which represents the south edge of pavement. And then number 2 is another fixed line which represents the north edge of pavement. Third is a fixed curve which represents the cul-de-sac bulb. Fourth is a free curve, which is essentially a fillet between that line and our main cul-de-sac bulb. Fifth is the same type of free curve except on the other side. Alright, let's do it. Let's create one. I've got the cul-de-sac kind of already there. I'll just get rid of that. So let's start a brand new alignment. Alright, first segment on the south side of the road. Now, these white lines are actually alignment offsets. They're there simply so I can use them as a guide. So I'll just pick that endpoint and this endpoint because I know what the offset is. Right, that's our first segment. Next segment is the line on the other side of the road. Now it's very important that you draw it in the proper direction. The one on the south is drawn this way, the one on the north is drawn this way. These entities must be drawn in the same direction. Our cul-de-sac alignment is going to go in this kind of rough manner. Everything must be drawn, in this case, counterclockwise. Third segment is my fixed curve. Now in this case, I know where the center of my bulb goes and I know where the radius is, so this is the component that I'm going to use. Here's my center point. I want it to be counterclockwise. My radius in this case is 15. Next is that free curve fillet. I could add it now, or if I feel like it, you know what, I can move these little line segments a little bit over. They don't really need to be moved over, but you know, I think it looks a little better, so I'll move them over. Now their exact positioning really is unimportant, because when I create this free curve, the right things will happen. It's a reverse curve. This radius is 12. This is also reverse curve and the same radius. There it is. There's our cul-de-sac geometry. Any change I make, all tangency is maintained. And there you have a method to create a perfectly dynamic cul-de-sac alignment where all tangency is maintained pretty much regardless of the edit made. Thanks so much. I hope you enjoyed this segment.